So what I'm going to do now is I'm going to talk about how to implement the command pattern in C++. We're going to define an abstract base class called user command impl, and this is the command role in the command pattern, and it basically defines the API that derived classes, or so-called concrete command implementations, can inherit and then implement to perform an operation on the expression tree when the objects are implemented. So this is the base class, and you can see that the base class is just a class that has a field or a data member called tree context, and tree context is a reference to the target of the command that are being run, and we'll talk about that when we get to the state pattern. We then have the constructor, which goes ahead and takes the tree context that's passed to it and stores it in the tree context data member. And then we have a virtual method called execute. And this is virtual because there's no implementation defined in the base class. We have to derive this and extend it in order to do something in the subclasses. But that's really the key API method that's used to indicate this is the command pattern. Let's take a look at a couple examples. So expr command is a user command impl, and it's going to store the string that is passed in by the user through a GUI or through a command line interface and so on. And then it's going to have an execute method that's going to go ahead and forward the request to the underlying tree context to be processed. So how this works, we keep a string that's the requested expression. We have a constructor that takes a context and the string that contains the expression, and we call up to the superclass, up to the base class, and pass in the context, because that's what's defined over here, right there. And then what we do is we go ahead and we take the string and we move it into our data member to keep track of the string, the string containing the user expression request. And then the execute method, when it's called, is going to go ahead and forward to the underlying tree context to perform the processing. Now, again, this gets us into the bridge pattern, and we'll see that whether or not you can do this operation or not depends on what state the program is in based on the commands that have been given up to this point. But for the moment, let's not worry about the states. Let's just say that when you execute an expr command, it forwards to the underlying tree context, which will attempt to carry out the command and build an expression tree related to that expression. And of course, under the hood, that will have been using the interpreter and builder patterns to do the actual creation of the expression tree, and then based on the state, the appropriate processing will be done. Okay, so that's just kind of illustrating a few things. Notice how this is using modern C++ nomenclature, where a virtual function is marked as override when you implement it. If you go back over here and you look, you can see that when we defined it, we said virtual void execute equals 0. That indicates that this is a pure virtual function. And then over here, when we implement it, we go ahead and override it. And that's just a nice kind of a documentation aid that says, I am now providing an implementation for this virtual method. Very much like in Java, they have these annotations that say @override, same kind of idea. Now, there's other kinds of commands we can have as well. So we looked at the expr command. There's also something called a macro command, and we use macro commands to implement so-called succinct mode. And in the macro command model, we're actually going to bundle up a bunch of different subcommands, and when the macro command is executed, it'll go ahead and forward to all of the subcommands that are part of the macro command. So we use this in succinct mode to basically take an expression, create a format command to make the expression input be in order, evaluate, which takes the expression and makes an expression tree, and then eval, which goes ahead and evaluates that expression tree to produce a yield, which is the output of the processing. Here's what this can look like. Macro command inherits from user command impl. We make ourselves a good old STL vector of user command objects, which are basically just encapsulations of user command impl using the bridge pattern to make the memory management easy to deal with. And then we have the macro command constructor, which takes in a vector of user commands, and then it goes ahead and stores them into the data member, macro command underscore. And then when the execute method is called here, that goes ahead and iterates through every element in the vector of user commands, the macro command vector. And for every command, we go ahead and execute the command. And this particular approach uses the C++ range-based for loop to run all of these commands, or really subcommands, to implement so-called succinct mode. And of course, you could implement this other ways. You could do it with an explicit iterator. I think there's pretty much no question that a range-based for loop is by far the most concise and coherent way of being able to do this kind of processing. So what we're going to do now is we're going to take a look at how I implement the command pattern in the context of the expression tree processing app when we look in the source code in a bit more detail. And I'm doing this for a couple reasons: to give you a more in-depth discussion of the pattern, show you where to go to find the implementation if you want to see the various parts, and also to demonstrate how these patterns can be applied together. So what we do here is we define a class called user command, and this is actually the abstraction class in the bridge pattern. And so its execute method, which you can see right here, goes ahead and forwards the call to the underlying user command implementation. And we'll take a look at that in a second. So this is the class that is actually used by the program. And you can see here that under the hood, it uses the same ref counter mechanism that we talked about when we were discussing the bridge pattern and the expression tree. So if you come over here and you look at the user command class, you can see that it takes a user command impl and stashes it away in that ref counter that we see over here called command impl. And then down here, you can see that when the execute method is called, it simply uses the bridge pattern to connect together the execute call and the abstraction, the user command object, into the command impl. And if you go over here and look at user command impl, you'll see that this is the base class of our implementer hierarchy from the bridge pattern. And this is what's actually implementing the command pattern here. But we're nestling it inside the context of the underlying bridge pattern just to deal with the memory management cleanly. So you can see here we've got a virtual destructor because this is intended to be used for inheritance. We have the execute method, and you can see that that is a pure virtual method. And then we store a tree context, which is used to keep track of the target. That's the target of the command that's executed. And then we define a whole bunch of different commands. We have format command, which is a user command impl, and it keeps the requested format as a string in its private data member part. We have expr command, which is a user command impl, and it keeps the requested expression as a string. We have print command, which keeps the format to use to print out the tree. We have the eval command. So each of these things is basically keeping track of certain information that's going to be used to do various kinds of processing. As you can see here, the quit command is just used to shut things down. So let's just take a quick look at the implementation of all this stuff, or at least some of this stuff. We can see here that here's the format command. It moves things into the format string. And when it's executed, it tells the tree context to please format or please to expect the format to come in with the format that was squirreled away in the constructor. And then it has a print valid commands that says what commands are going to be usable at this point. Expr command, we already looked at this. It's going to go ahead and forward the string that contains the user input expression to the tree context when it's called, and so on and so forth. All these things pretty much work exactly the same way. And you can see here that they stash this information away in their constructors, and then when their execute method is called, they call the appropriate method on the tree context. So this gives a consistent API to the user where we're only going to be executing commands, but then the execute methods under the hood will do the appropriate transformation to make the call on the target with the appropriate method. So execute for print command causes print. Execute for eval command calls evaluate, and so on and so forth. So that's just kind of walking through the implementation and showing how we implement it. And it also demonstrates how we encapsulate this hierarchy behind a nice, simple object called user command. And that's what's actually seen and worked on by all the other parts of the program. And under the hood, that uses the bridge pattern to connect the pieces together.